there was this mismatch in understanding communication between the engineers and the managers. And I feel like I'm seeing that happen in autonomous vehicles and agentic designs and all of those things where sometimes security people are raising their hand and like, hey, like this isn't good enough. We're going to have issues. And the other side of the table saying, we got to get this out. We're under pressure. It's going to cost too much to do what you're talking about, et cetera. It's the same story that we hear over and over and again in security, where the needs of the business, the concerns of security kind of come to a head, and security is oftentimes getting swept under the rug.
Many drones can already fly themselves. Robot taxis carry passengers, and AI systems are becoming more autonomous every day. It's happening. The question is whether we can trust those systems to avoid bad decisions and resist attacks that can cause harm in the real world. Welcome to the Security Cocktail Hour. I'm Joe Patti.
I'm Adam Roth.
Adam, we've been talking about drones on a lot of episodes, and we have a guest on, and he's going to tell us a little bit about what we should really be worrying about. We've got Chad Butler. Chad, welcome.
Thanks, guys. Thanks for having me on. Appreciate it.
You have been sounding the alarm about some things that can go wrong with drones. So, tell us, what should we be worried about besides terrible pilots like me crashing into stuff?
My involvement with drones was back in about 2018. So I was working at Amazon. It was at AWS doing product security, and an opening came up to lead security for Primaire, the drone delivery program. And I was like, this sounds awesome. I want to be involved with this. At the time, what we thought was that we were going to launch imminently, and that I was going to build a program to make sure that everything was going to be secure. And that included everything from the traditional kind of cloud security aspect of, how do you run all of the routing and the delivery stuff that has to happen in the cloud, to what's actually running on the drone itself, the hardware, as well as the software, and then the compliance aspect of how do we comply with an FAA rule which has not been made yet. How do we look around the corner and try to figure out what they're going to expect? And so that was kind of my involvement. There was autonomous drones, but then self-driving vehicles, autonomous vehicles, that's very similar. And now with AI, we see a lot of the same things, right? With agents doing things that humans used to do. And so that was kind of the landscape of where this sort of resurfaced for me. And I saw, I think it was a Reuters article that said Amazon had pulled out of the Commercial Drone Alliance organization, which is kind of like a conglomeration of a bunch of different drone delivery companies who are trying to lobby the FAA to get rules that will work for their organization. And Amazon pulled out of it. And as I looked into that, I could kind of read between the lines a little bit, and I saw a little bit more. I guess you could say I saw the story behind the story, which was, the Commercial Drone Alliance was arguing that the rules or the proposals that the FAA put out were too stringent and too strict, and they were lobbying for something that was a lower requirement. And the problem is what they're arguing for kind of removed a key control that made GPS spoofing and drone capture and takeover easier to pull off. And so that's when I kind of raised my hand and said, we shouldn't be doing, we shouldn't be lowering the bar just because it's maybe harder and more expensive, because these are, flying objects that are kinetic objects that when they fall on people or things, they cause damage or injury. So that's kind of how I came into it. If you look at, regulation wise, up until, it's still the case that Part 107 from the FAA is what's required to do commercial flights, right? To pilot a drone and do so for commercial reasons. Part 108, so Part 107 allows you to do that, but you have to remain in visual line of sight at all times, unless you have a waiver. So for the last, what's it been, since 2016 up until 2025 and still ongoing, you had to go through a waiver process, which was very involved, very expensive, which means the only organizations doing that today are the ones that can pay the big dollars to go through that process. The FAA wants to get through Part 108, which allows beyond visual line of sight for everybody else, right? And so we're kind of at this point where when Part 108 goes live, then presumably it'll be much easier for drone deliveries to happen or commercial drones to fly beyond visual line of sight, which you would assume would mean we would have more drones flying beyond visual line of sight in our shared airspace, right? So that's kind of the landscape of where we're at with this.
Chad, now, if I understand a lot of your work, we've been talking about drones, so we can get the drone hashtag and all, and our listeners
Mhm.
like it. But also, if I'm not mistaken, you actually talk about a lot of these issues with autonomous systems in general, not just drones and not even necessarily kinetic systems.
Yeah, I've spent the majority of my career in product security, and it's mainly been on software side, building secure software applications, all of those things. Um, More recently, doing that with AI, figuring out how do you build secure software with AI coding agents. Um, you don't have to look very far to see issues that come from that. But a lot of the concepts are the same, and I found the same thing going over to Primaire. I'd spent a lot of time doing software, very little time doing hardware. I did a few projects at AWS that were hardware related, but what I found is that the principles are very similar. It's you have data coming from trusted or untrusted sources. You're doing something with it, and you're taking actions as a result of those things. And hardware is very similar. Whether it's you're getting data or sensor data from GPS or lidar or radar or magnetometer or whatever, and then determining, is this data source trustworthy, and is it trustworthy enough that I can make routing decisions that with confidence that I believe will get me where I need to go without causing any issues in the process. So it's a lot of similarities there.
It's ironic because today on LinkedIn, one of my colleagues from my university, he was talking about I can't wait to how hot is it to start hacking AI robots. I'm like, I can't wait to do it. I'm like, it's being done now, and what we talk about is untrusted sources because not everything is locked down. It's very similar to a computer, right? You might have a USB port open, you might have a keyboard, you might have Bluetooth, you might have Wi-Fi, and these autonomous vehicles are pretty similar. Things can be done like that, so we have to be very careful.
And one of the things that I keep seeing, unfortunately, both in autonomous vehicles and drones as well as AI, you know, we're we're trying to make these systems safe and behave safely in kind of optimal environments, and we're still having trouble. The proverbial ball goes out in the road, the kid chases it. Do we detect it? Do we do the right thing? Um, there's still things in the natural environment that I think the autonomous systems aren't handling well all the time, right? And that's understandably. There's a lot of it's very understandable. There's a lot of variables out there. But my thing is, we haven't even really gotten to the point where we're saying, okay, well, now let's deal with the threats of somebody who maliciously wants to take control of this or do something bad, right? There was a research paper a few years back, I believe. I think it was a research team out of China who showed, very simple, paint over a white line and paint a new white line, driving the car off of the road. And will the car follow that? And I think they were using like a um, special type of paint that was kind of like photoluminescence or whatever, so that it didn't really look out of sorts until the lights were off. But the response from the autonomous vehicle industry was, yeah, but nobody's going to do that. Like that's not a realistic environment, which is what we hear in security all the time. Hey, you've got a vulnerability. Yeah, but that's really hard to exploit. Nobody's going to do that. And of course, the three of us know, and probably all the people watching this podcast know that the moment you say that, that's really hard. Nobody can do that or nobody will do that. Like it incentivizes everybody to go and do it,
Yeah,
right?
that's
So
a
they're
challenge
going to
for
do it.
yeah. Yeah,
Yeah,
and you're right because even besides the malicious part, I think the thing with painting the line is really funny. Because think about that. Think about maybe though something not necessarily malicious, where the line gets painted, and things like that need to be done very precisely, and maybe it's not quite done the way it's supposed to be. That they made a mistake or something, and it doesn't show up right away. Like a lot of cars or a lot of devices can deal with it, and that's fine until the one comes along that can't, and all of a
Right.
sudden you have a big problem. Even detecting that there's a problem with them can be very difficult.
it's like the Waymos, right? They came to an intersection. There was a video about it. It was like 3 or 4 Waymos. They came to an intersection, and they all had problems with contention because none of them had priority, so none of them moved. And the one person that was in a regular vehicle, I think if I might be like really paraphrasing this, but like the guy got frustrated. Like these Waymos, like, oh no, I'm not going anywhere. They're all sitting there. They just
Yeah.
happen to not be able to navigate their own algorithm.
They're all like,
Did you
after
see
you,
that,
no, after you, after you, no,
Chad?
after you.
Yeah,
I,
Yeah.
I didn't see that specific one, but I've heard other situations where they get in a place where there's just no good way to go forward and they just stall and they can't move. Yeah. And I mean, I think the other thing that's interesting here is like, don't get me wrong. I legitimately feel that autonomous vehicles will get there and it will probably, save more accidents and deaths than it causes, but it's the whole personal risk calculation. The same reason why somebody is much more likely to get killed in a car accident 5 miles from their house than they are to be killed in a commercial jet crash. But everybody freaks out when the airliner goes down because that feels so much worse, right? You're not in control. Whereas if you're in the car, you got the steering wheel and somebody falls asleep and drives off the road, and you're like, oh well, it was an accident. That sucks. It's accidents happen. But when it's somebody else is behind the controls or an autonomous system behind the controls and there's a crash, somehow that feels worse. It feels more concerning and risky. So we tend to react uh, more what do you call it, more aggressively, if you will, or risk averse to things where we're not in
yeah.
control.
Well, I think we see some of these things, and like an autonomous vehicle, and there's an expectation that it's going to work and that it's not going to make spectacular failures. And so in a sense, they are kind of held to a higher standard than people. I mean, I think you're absolutely right. People are terrible drivers. I mean, I'm here in New Jersey. The
I was
place
just
is
going
a
to say that.
nightmare. I can't imagine an autonomous system that could be worse. But it's like, when we see someone do something stupid on the road, we're like, well, we can't fix stupid. But we can make better autonomous systems. We have an expectation that they'll be better.
Yeah.
And that goes back to saying the whole thing. Like there are people out there that really shouldn't drive. They get into accidents all the time. Wouldn't it be better to put them in an autonomous vehicle that would probably make better decisions than them? Let's be honest. AI is not going anywhere. Autonomy is not going anywhere. And it's
Yeah.
similar to what I'm doing. I'm working on a paper on cyber warfare. The main thing here, the real takeaway, in my opinion, is there's nothing wrong with all this technology as long as you create the right framework, the right policies, the right
Hmm.
procedures. If you put those in place, then you have the 80-20 kind of rule, right? And I hope it's better than 80%, but the 80-20 rule is like 80% of the time you're going to have really good experience, 20% you might have failure. Well, we need more like 98, 99, and then 1, right? But if you put the right policies, the right frameworks, the right legal stuff, you will get to a point because the main thing is people don't always care about loss of life. They should. People care about litigation. And if you can put things in place where people want to avoid litigation, I mean, I'm not saying people don't care about people, they do. But let's be honest, like if somebody knows that there's a possibility of being sued, they're probably going to step it up just a little bit more.
I think what you're touching on, like, there's a huge public perception issue, right? It's whether it's safer or not is almost meaningless because it's what the public perceives. And if there is a catastrophic failure of an autonomous system that causes loss of life, that's going to get news, right? It's going to be at the top of the news feed because it's extraordinary. It's a big deal. And in a lot of ways, I think it's very similar to where cloud was, what, like 10 years ago, where people weren't willing to go to the cloud because of cybersecurity. I can control the cybersecurity in my data center better than I can in the cloud, and so I can't do that. And when I was at AWS, we used to have a saying that we repeated a lot, which was, "A bad day in the cloud for one of us is a bad day in the cloud for all of us." So if AWS or Google or Microsoft had a security breach, all of the other cloud providers were going to be under increased scrutiny because that's where the attention was. And so regardless of whether it was related to your cloud provider or not, you're going to be asking your cloud provider, are you vulnerable to this? What are you doing? How are you protecting me? So, I would argue that these commercial drone delivery providers, they shouldn't be trying to get the lowest bar necessary. Like, they should be trying to get whatever is necessary to make safe operations possible, because as soon as one of these drone delivery drones um, injures or kills somebody, like, it's going to be a bad day for all of them. I guarantee it. People are going to revolt and cause all sorts of backlash because of that.
Yeah.
You can deal with it
You
now
know
or
what that makes
later,
me
but I think it's better now. Right?
you know what that makes me think of that just popped into my head? Something like it's like you say, it's a bad day for everyone. If you have a mistake like what happened with CrowdStrike, that bricks huge amounts of machines. God, what could a bad software update or a bad AI update do to thousands of autonomous systems running on it? My
So,
God.
so
Wow.
everything is risk versus reward, right? How many drones are saving people's lives by delivering defibrillators? How many drones are delivering possibly a blood supply that nobody else, like a rare blood, to a hospital for some from another hospital? How many ones are delivering organs that normally couldn't get there? We don't want to talk about not doing something. We want to talk about putting the right procedures, policies, and framework in place to minimize any loss of life and any other issues. That's what we want to talk about.
I can't remember if it was I heard this from the FAA or the NTSB, but basically the gist of it is every one of those FAA rules was written in blood. It's there because some accident happened, somebody died, or maybe there was a near miss or something like that. There's some wisdom behind these rules that it's there to prevent these types of things from happening. And so I think the FAA is probably going to come down. I mean, I hope they come down on the side of safety, even if it's more expensive and inconvenient to certify. That's my hope. But obviously, I don't necessarily have a pony in this race, other than drones flying overhead, and I don't want them to fall on top of me.
Yeah, I think everyone does. Exactly. As much as I need my fidget spinner delivered before midnight, I mean, we got to walk down the street too. So, Chad, some parting thoughts. I mean, what should we have our eye on in this space? What worries you about it that might happen soon that we don't have a solution for yet?
So the thing that comes to mind for me is it's the same problem we've seen for a long time. And in fact, if you go back, I think the Challenger shuttle disaster happened 40 years ago. In fact, I think it was 40 years ago this year, if I'm not mistaken. Um, when that shuttle disaster happened, There was a presidential commission put out there to investigate the cause of the accident, and they issued a report called the Rogers Commission report. Um, there's one appendix to that, and I think it's like Appendix F or something like that. It was written by Richard Feynman, the famed physicist and scientist, very brilliant. But he goes through and approaches this very systematically and scientifically. And what he found is that there was this fundamental breakdown in communication. And I'm probably going to misquote the numbers here, but basically they said if you talk to NASA management, they felt that the risk of a shuttle disaster was something like, 1 in 1,000 or 1 in 10,000 or something like that, right? What it basically boiled down to was you could run a shuttle mission a day for years and never have an accident. If you talk to the NASA engineers or the space engineers, they felt like the risk of shuttle disaster was about 1 in 100, which, basically you're rolling a die every time you launch the shuttle. And so the understanding was wildly off. There was this mismatch in understanding communication between the engineers and the managers, and they made a launch decision based off of an assumption that it was safer than it actually was, right? And I feel like I'm seeing that happen in autonomous vehicles and agentic designs and all of those things where sometimes security people are raising their hand and like, hey, like this isn't good enough. We're going to have issues, and and the other side of the table saying, yeah, but we got to launch this. We got to get this out. We're under pressure. It's going to cost too much to do what you're talking about, etc. It's the same story that we hear over and over and again in security, where the needs of the business, the concerns of security kind of come to a head, and security is oftentimes getting swept under the rug. So that's what I've been thinking about lately is, that appendix that Richard Feynman wrote 40 years ago. It's like he's still right, and those communication gaps are still there, unfortunately, and we see issues from it.
That worries me. I'm sorry, that worries me because as I start doing research, I'm subject to an IRB, I believe it's an institutional review board. And in order to do research, obviously there's nothing ever perfectly written in writing about any research. But how would one group have 101 and one group have 1,001? That is nowhere near each other. And is that based on quantitative data that was analyzed, or is that more of emotional data, right? Like,
Yeah.
oh, I see this issue. You have to quantify what it is in order to really understand. You have to do research. Was there two different groups doing research, or was it more about some emotional aspect of it? And plus, if one has 100 and one has 1,000, they're definitely not working off the same data. Because if they're
Right.
working off the same data, they can't make different decisions. So that's a very, very interesting thing. I'm going to look into that further because now my head is just spinning from that.
I mean, the two things that I remember he mentioned, one, the space program has been political, right? And it certainly was 40 years ago. It was like the space race, right? And even after the first to put a person on the moon, satellites and all of those things, it was a way to flex your national muscle, so to speak. So there were political aspects, I'm sure. But the other thing that Feynman mentioned was there was very much this attitude of problem solving where engineers would say, "Hey, we've got this problem," and he said, in a healthy engineering culture, managers should say, "Okay, that's interesting. Tell me more about that. What can we learn from that? What can we do about that?" But in NASA's case, it was like, "Oh, you brought me a problem. Well, go fix it. Don't bring me problems, bring me solutions," right? You've all heard that before. And so by NASA management taking that approach, they were basically punishing anybody who brought issues to them, because now it's like, you brought me an issue, now you own solving it, it's on you to get it done. as opposed to the manager saying, all right, we've got an issue, let's figure this out and find a solution together. And so, like, you set up
Yeah.
that leadership culture, and now people aren't bringing issues to you, right? They're because they're not getting the support they need to get it fixed.
Or don't raise an issue because then you own it and you have to do more work.
Hopefully, we don't have that kind of dysfunction in organizations putting together autonomous systems, especially in the kinetic world, because, we know NASA had some culture problems. We know the auto industry has had some problems with saying, you know what, we'll just let it go. We'll pay off the victims' families, whatever. It'll be cheaper. I hope that we've collectively learned the lesson that we shouldn't let that happen, but we'll see.
For sure.
Thanks so much for joining us. This has been very illuminating, a little bit scary, but if we're going to move ahead with stuff, we have some things we need to solve.
Well, thanks for having me on, and I apologize. My intent is never to spread fear, uncertainty, and doubt. But sometimes I feel like my role is to just try to connect the dots and make sure people are aware of the risks. And so sometimes that's scary.
It's all good for provocative thought.
That's right, and it's something we need to deal with regardless. So thanks again for joining, Chad. Adam, always good to see you. And thanks everyone for listening.